Okay, guys, doing a video for you. Obviously, Geomagnetic Storm is here. The solar wind got here, started last night. I was going to pop in early this morning when I first seen it starting to happen. But I didn't do that, so anyway, I'm here now. And yes, we just now made it to a G level 1 storm. Okay. Actually, I bet it just hung around there for a minute and probably dropped back down. I'm not sure yet. The wind speed there, 563. Okay. So we'll go down here. No, it's still at the storm level. Okay. The model update I made, I did that before I looked at this. The space weather part of that will not have this yellow line in it. But anyway, we are at a G1 storm right now. Okay. This is not going to stop. And this coronal hole we're experiencing right now that's causing this was large. And it still is large. And this is the same coronal hole that gave us Geomagnetic Storm Level 2, the G2 storm, about 27 days ago. Why 27 days? Because that's how long it takes the sun to rotate at the equator where the holes are. Okay? So this particular hole we're experiencing right now has hung around for 4 months. In other words, 4 cycles. It came right through. Okay? And the last time it came through, it gave us G2 storms. It brought Auroras. It brought them all the way down into like Colorado and places like that. I think it might even been just a little bit further south. So remember, guys, the Auroras, the higher the geomagnetic activity, the further down they come in latitude. In other words, they get closer to the equator where people can see them. Okay. The smaller storms where we get the Aurora, the photographs and stuff, are usually typically a little further north towards the poles. Okay, and if you're in the southern part, obviously towards the southern pole. So anyway, I did want to show you guys that, bringing that to you real quick. Now, we're going to talk about this just for a second, though, okay? This is the Enlil model. This did not look like this yesterday. What am I talking about? I'm talking about the green line here. Okay, that's the conditions at Earth on this graph. Okay, the line I just put there, that's showing you the velocity. In other words, the speed of the charged particles, the solar wind. Okay, what I find interesting, yesterday, this was doing this. Okay, it's no longer doing that. It's went up here and it seems to have stayed there. Look how long it stays that high. 2 days. So, if this holds true, if they're forecasting this out and it's holding true, we're going to experience storm levels for 2 days. Most likely. Now, I know you guys are looking at the top graph too. That's the density. Okay, see how it peaked up here and then it started dropping out? Why did it drop out? Well, typically the density will drop when the solar wind speed goes up. Okay, they do the opposite typically. Now, when we get like extremely hard hits, sometimes it's at the beginning of a solar storm or what have you, or a CME or whatever. When those go up at the same time, that means we take a harder hit. So when they're doing this is very normal. And obviously they got the density staying down because the wind speed was up. You can kind of think of it like this, guys. If you put a ping pong ball on like a table and you blew on it, right? You could probably blow that ping pong ball across the table pretty fast, right? But you put a golf ball, which is higher in density, on that table and you blow on it, you're not going to be able to get it up as fast. That's the analogy I'm using here because it's very relevant, because those two objects are different in density, but you're trying to blow it at the same speed, right? So that's actually what's happening here. That's why that happens. So I did want to explain that real quick. But I do think that this thing is going to hang around now for a couple days, and it makes sense because the coronal hole was big. Now here's that Aurora forecast I was just talking about. I put it in my model updates. You guys know that. So you can see how far down they're predicting it to go. Now, if this geomagnetic storm ends up being stronger than what they think it's going to be, you will see this graph change, this forecast model change. You'll see it come down further. Okay, so right now, let's see the time. That's as we speak. Right here, as I'm making this video, right here in Canada, there's a 90% chance that they're seeing auroras right now. Okay, see the graph here? It's about a 90% chance that they're seeing auroras. So, and as you can tell, because when we rotate through, so all this is going to move this direction. Okay, so the larger part of this, typically, it's probably going to come down. We're going to start seeing it in the States. Probably already are. Well, Maine, it's going across Maine right there anyway. So, what I'm saying is, we may get some really good aurora photographs from this. We got some pretty decent ones last month on this. So, I wanted to point that out, guys. I just think it's one of the neater parts of what we talk about. Now, again, all these models are showing exactly pretty much what we would expect for a storm, okay? Everything's spiking right there. Something I've noticed, and I'm not sure if this happens every time, but again, because I'm still trying to learn everything I can about this kind of thing. You see this? You see the storm levels here? How they're virtually not there, pretty much at zero. I noticed that a lot right before we get these storm levels, or the bigger storms, or even a small storm like we're experiencing right now as far as intensity. It seems like the day before, the geomagnetic storm level just drops out to nothing. I don't know if there's some science behind that or not. It's just an observation I've made. And, I'm going to research that because it just kind of hit me in my brain here today. And I want to research some of that, see if that's actually what does happen most of the time or all the time or whatever. But yeah, I mean, so I am going to pause here. Okay, guys, here's one of the models. This is the newer one, guys, and I like this one, okay? The other one's good too because it's old, but this one here, the visuals on it really kind of gives you better of an idea of what's going on. This is the velocity model of this. And on this particular model, the sun's on the left side, okay? So it's over here blowing this way. I hate using that word blow on talking about solar wind because it's just charged part. It's not really like wind like you would typically think. But yeah, so you got that right there, and I'm going to push play, and we're going to watch it. Now, guys, it's going to look intense, and it is, but it's not the most intense, crazy stuff we've ever seen. All right, now, I'm not trying to downplay this either because we could definitely see some effects of this. I do think that earthquake risk definitely shoots straight up, considering that we're now over 100 days without a 7.0 earthquake. We had a 6.4 like yesterday out in Ascension Island, out in the middle of the Atlantic, but they're all following the fault lines, which is what they really should do. So, but I want to point that out because, yeah. Let me push start here. Okay, and there you go. You're going to see hits on it. Okay, and this is all this is showing is the velocity, the speed that it's moving. Okay, so when you couple velocity with density, that's typically what gives you the pressure. The combination of both of those is what gives you pressure, whether it's light pressure or heavy pressure. Okay, now you can tell this is not going to stop. This is going to keep going because the coronal hole was large. All right. So here's the density one. All right. Now, sometimes, guys, we see like really low solar wind, but yet our magnetopause and our magnetosphere and our shields are going crazy, right? Well, a lot of the times it's because it's high density. It's just denser material. So that can have a big effect too. And I've talked about that. I think it has just as much to do with stuff that hits us as the solar wind speed itself does. So if they're both high, that's when stuff really happens. Okay, big time, like big stuff. Now we'll go down here to the pressure. Excuse me, sorry about that. Now I find it interesting that the pressure, see how it's kind of engulfing the earth there, and you'll see it kind of creep in from the backside. That is normal. Okay, don't let somebody tell you that that's not normal, because it is. That happens a lot. All right, now I'm not sure the exact science behind it, but the way I understand it is, when we get hit, it kind of does one of these. So it's still actually coming from the front, but because it's wanting to follow the magnetic field lines from our poles, north and south, that's what does that. Okay? That's part of what causes that to happen, if I understand that correctly. So, but yeah, I mean, most definitely we see stuff in the backside sometimes that is legit. All right, but a lot of times it's not. It's just something that happens. It actually came from the front and not the back. Cosmic rays, most definitely we would probably get those from the back or from below, top, any direction. All right. Keep in mind, cosmic rays are really, really radiation danger, big time. So I talked about that yesterday with pilots and stuff. So, okay, guys, I got you over here at SDO. I want to show you the coronal hole that's actually giving us the issue and stuff right now, and what's actually to come. Okay, so what you're seeing here, you're seeing this hole. Okay, that's what's giving us our issue right now. It's already rotated past us. It might be catching us a little bit, maybe. Now notice again on the 211, the purple version, it looks like it's opened up more dark there, right? Well, it's because of the light spectrum that we're looking through right there. Okay, it's the 211. The one on the left is the 193. We're talking about angstroms there. It's extreme ultraviolet light. We can't see that with our eyes, so they put these filters on it. We're able to see what's going on here a little bit more in detail. Now, you can even see on the 193 how it's a little bit darker shaded right in here. Okay, so if you go over here and look at this one's showing it to be open even more. So the atmosphere on the 211 looks like it's open more, and it always does. Okay. But what I find to be what we need to be paying attention to right now is this, because we can't do nothing about any of this actually, but this is not what we need to worry about now, because we're going to get that regardless. It's here. This is behind that one, so I think that this storm level has a potential to hang around for a minute. They're already predicting it to hang around for a couple days. And the longer they hang around, the more intense they seem to get sometimes, because they're constantly pushing energy at us, right? So, our atmosphere absorbs that. So if it's getting constantly bombarded, it would slowly raise, and just makes sense that way. Now, there might be some release points or what have you that happen throughout what's going on there. Sometimes we're like a capacitor sometimes, and we'll shoot off some of that energy when we can't hold anymore. And I've talked about capacitors before. They just store energy. We use them here in machines and what we do in our lives, but we're able to control when that energy gets released. When we're talking about like a battery capacitor, and they use them in transformers and stuff like that with electricity. It just holds energy. It's like a big battery, basically. I'm not going to go much more into detail with that, but it will. We can only hold so much, and it has to let it go, right? And that's part of why the earthquake risk goes up. We got to pay attention right now, earthquakes, guys. Just have to. Like I said, we're 100 days, more than 100 days since the last 7+. We're supposed to get one every 20 days or so. And yeah. But anyway, this was yesterday. Okay. Now, if you notice, again, it seems like more stuff is popping up behind this coronal hole. This stuff is starting to open up as it gets to be Earth facing again. This is happening over and over and over and over again. And so there's something to say about this, guys. And Scott's been talking about it. He had that one video talking to the insider, talking about the torsion, which has to do with the equator moving at a different speed than what the poles do on the sun. So it kind of torques it. And torsion is what he's talking about. So, but anyway, I'm not going to go into that, but I just want to show you the difference. Okay. So I do think that this storm has the potential to hang around a little bit longer than what they're showing. It may not, but I do think it has some pretty good potential there. What's up, guys? Back here. This is the 171 angstrom. I'm going to show you guys something here real quick. Okay, guys, I'm not going to do this 171 angstrom real quick. I'm going to do this instead. I may take you in a minute to go see the 171 on SDO. Anyway, I told you, solar wind brings some radiation with us, and this is showing some intense radiation. Now watch this. The pink is very, very intense. It's as high as it shows, okay? And it always comes in at the bottom like that. I think this is a top-down view, if I'm correct. You see the dark side of the Earth there, so the sun would definitely be off to the right here. But I think this is a top-down view instead of a sideways view, okay? It's hard to understand that because we're looking at a two-dimensional model, trying to apply it to a three-dimensional thing. But yeah, so watch this. Okay, see it come in, it spirals in. Even got another hit right there. And watch what this does. It's spiraling in. Look how it just like gets closer and closer. Now, you see that jump like that? What happened there? Remember, I always tell you guys, if you're looking at these models like this, you see a massive jump like that, you always need to look and see if it's missing time. That's exactly what happened. It jumped a few hours time here. Okay? So, that's not necessarily an odd thing to see. The thing probably went into safety mode because of that high energy. And so it came back on after it came out of safe mode. Okay, guys, this is the Geoelectric field model. And this is a regional model. Okay, what that means is that we're just looking at the United States or North America, however you want to say it. But this is a new tool, okay, fairly new. It's like a couple months old. So to sit here and say that something's very, very intense on this, I can't really tell you that. All I got to go off of is what this graph shows, the bar down here. So if you're looking at we're seeing some yellows pop in there, right? So the yellows are like right in the middle. At, what is that? It says 100. It's an intensity scale, so it's at 100. I'm not sure exactly what unit it's actually looking for there. I mean, we could look at it real quick and see if we can figure that out. But I want to explain a little bit about this, what I know about this. What this is trying to show you is the effects that the geoelectric circuit, basically, is operating on our electrical grid here, okay? Yeah. I don't know why that's doing, there it goes. Okay. The geoelectric field there, okay? Now, you see it jumping around, right? You see in a couple different waves. You'll see it start around right here, and it kind of waves this direction. Watch it do it. It does it like 3 times. See that? Okay. And it does, there it went again. And I guess maybe that, because what this, like I said, what this is showing you is the possible effects or how intense this is hitting our electrical grid here. Okay, how it could possibly be disturbing us as far as, power outages and stuff like that it goes, I guess. I do think that this would probably not really mirror where the auroras are being seen, but I think it could kind of, they could kind of coincide with each other a little bit to say, hey, yes, we were getting in that area, we were getting some pretty intense activity, and that's the reason why we've seen auroras down that low. Now, I will say, because I've had a few questions, this right here, and I think I know what's causing this, okay? You see this dark patch that never goes away? Typically, if this is normal, okay, in ambient, basically, in ambient conditions, which means just general position or normal position, this is kind of a darker blue, the whole thing. Okay, so when you see this dark blue patch right here, when other stuff's going around it, that's the Appalachian Mountains causing that. Okay, I'm not sure why. Maybe it's because the electrical grid there isn't as good because it's on a mountain range. I don't know. But you can also see it over here. Why? The Rocky Mountains. Okay, that same shape always shows up. It almost looks like an arrow like this. Okay, but yeah. That's what that is. I just thought that was, you guys would want to see that, because this is really the first storm I've actually used this model on, and it is showing some disruptions. Now, that doesn't mean we're seeing power outages and stuff. I'm just saying we're seeing some disruptions on this. So, okay, guys, this is a really cool article. I'm going to show you guys this. I didn't see this article, and I watched Mr. MBB3's video, and he was reporting on it, so I went and did some digging myself and found the article and all that kind of thing. And I'm going to show it to you guys because it's definitely worth looking at. It's a gravitational wave. We get these things all the time, but they're almost always invisible. Okay, so I'm going to play this video in just a second, but do you see the ripples here? Okay, I'm just going to give you a basic general whatever here. It's kind of like throwing a rock in a pond and you see it ripple out, right? Okay, that's kind of what's going on. Not completely technically like that, but it's very close. Anyway, do you see this brown right here? That's actually dust off the continent of Australia. This is where this gravitational wave started at, and it, obviously that's where it happened. And it's because Australia is having that huge heat wave, and they had some storms come through, and they're saying that it was this cold air rushing that caused this gravitational wave. Now, why could we see it and we typically don't? Well, because it went through clouds and picked up dust and all kinds of stuff. So you weren't really seeing the actual, technically, the wave itself. You were seeing what the wave was doing to the clouds and the dust here. Okay, so obviously we can't physically see gravity, so that it makes no sense that we would be able to actually see, that way. But I'll push play here and we'll check it out. Okay, just keep in mind, and that dark you see is just a satellite going by during the night and coming back in during the day. So just watch it right there in the middle. There it is, starting. You see that? Isn't that pretty cool? But I did, like I said, I just wanted to show you guys that because I just thought it was really neat. We don't typically see these. They're rare to catch. Very, very rare. And it was strong enough that it picked up dust off the continent there and took it out that far. And it gives you exactly what's going on here. It explains to you what's happening. Again, it's pretty much just said what I just told you. But pilots have to deal with it because of air turbulence. And you see how fast that was moving. So, I mean, yeah, that's moving pretty good. Okay, guys, I got you over at SDO. I'm going to show you guys this. I posted this in the Facebook, our Facebook group page, the Planet X News Facebook group page. I encourage you guys all to go over and join that group because there's a lot of good conversation that goes on, a lot of good articles get posted, a lot of good captures, and obviously Scott posts there a lot and shows a lot of his info. Everybody gets accepted unless we know that it's somebody that just wants to be there to cause problems. And then after that, if people start being extremely rude and stuff like that, especially to other subscribers and all that, we have to handle that. But anyway, I encourage you guys to come over and check it out. Now, what you're going to look at here, it's a filament release, okay? And it caught me because it was extremely fast, okay? You're going to see kind of two filaments dancing around here a little bit. They look like lines, and it's right in here is where you want to look. You'll see one go one direction, and then you'll see the other one snap back the other, and then when it snaps back like that, it moves fast. So I'm going to play, I slowed it down. Okay. I'll speed it back up here in a minute. But do you see that right there? Okay. And again, the sun was releasing stuff there. It was a filament that was getting released. And I couldn't really tell if it actually ejected enough, strong enough to get away from the sun. But, seeds is down again. LASCO C2 at seeds. So it's hard to see if we're even getting CMEs and stuff. I think I might have seen one the other day, actually from earlier today. But yeah, I think we might have had one and we just haven't seen it yet because the data's not there. So I'm going to speed this back up and let you guys watch it again. Okay, sometimes you see it better if it's moving faster. Right there went that one. See that? See how fast that went? And I've even got this slowed down. It's crazy. Again, it's in here. All right, I'll leave that there so you guys can see it. It's getting ready to happen. Sorry for the quiet there, but I just want you guys to see this. Here it comes. That way, and then boom. See that? That was, in my opinion, was probably an ejection. It probably ejected that out. It moved very, very fast. But we're not going to know because the tool's down. You know, that does look pretty similar. And we've seen something similar up here too today. Now watch this. It's almost like this thing is like we were talking about the plasma getting drawn into our object. It's almost like what we're seeing there. It's crazy. Just watch. It's right in there. And it's almost like it's round, but I don't know if it's, see that? And then it'll come back from the other way. Watch. Oh, come on. Sorry, guys. To the right, and then watch. See that? And then back the other way. Okay. Now, I know it's kind of hard to see. I get it. But I really wanted to show you guys those two. You know, again, we're not having any seeds updated data for LASCO C2, so it's hard to see where these CMEs are happening. I'll probably go check out Cactus here in a minute, see if it might have picked something up, if it's updated. But we're seeing, you know, and I'm going to talk about the seeds thing in my next video. But yeah, guys, I'm going to go ahead and end it here. Just keep in mind, earthquakes, geomagnetic storm level is definitely not going to get much better. It'll probably might just continue where it's at or get greater, at least in my opinion. So anyway, guys, God bless. Yeshua saves, and you can drink this Kool-Aid.
Listen to yourself, turn world, serve its own needs, dummy, serve your own needs, feed it off an ox, speed, grunt, no strength, the ladder, start to clatter with fear, fight down, high, wire in a fire, represented 7 games, and a government for hire in a combat site, left the West coming in a hurry with the furies breathing down your neck, team by team reporters baffle Trump, tell the crop, look at that low playing, fine, then, overflow, population, common food, but it'll do, save yourself, serve yourself, world, serve its own needs, listen to your heartbeat, dummy with the rapture and the reverend in the right, you vitriolic, patriotic, slam by bright light, feeling pretty sight. It's the end of the world as we know it. It's the end of the world as we know it. It's the end of the world as we know it. I feel fine. 6 o'clock TV hour, don't get caught in forward towers, slash and burn, return, listen to yourself, churn, locking in, uniforming, book burning, bloodletting, every motive escalate, automotive incinerate, light a candle, light a boat, step down, watch your heel crush, this means no fear, cavalier, renegade, steer clear, tournament of lies, offer me solutions, offer me alternatives, and I decline. It's the end of the world as we know it. It's the end of the world as we know it. It's the end of the world as we know it. And I feel fine. I feel fine. It's the end of the world as we know it. It's the end of the world as we know it. It's the end of the world as we know it. And I feel fine. The other night I jumped nice, continental, drift divide, mountain shit in a line, land nerd, Bernstein, Lambert, Brezhnev, Lenny Bruce and Lester Bangs, birthday party, cheesecake, jelly bean, boom, you symbiotic, patriotic, slam book, net, right? It's the end of the world as we know it, and I feel fine. It's the end of the world as we know it. It's the end of the world as we know it. It's the end of the world as we know it, and I feel fine. It's the end of the world as we know it. It's the end of the world as we know it. It's the end of the world as we know it, and I feel fine. It's the end of the world as we know it. Harry Truman, Doris Day, Red China, Johnny Ray, South Pacific, Walter Winchell, Joe DiMaggio, Joe McCarthy, Richard Nixon, Studebaker, television, North Korea, South Korea, Marilyn Monroe. Rosenberg's H-bomb, Sugar Ray, Penn, John Brando, the King and I, and the Catcher in the Rye. Eisenhower vaccine, England's got a new queen. Marciano, Liberace, Santayana, goodbye. We didn't start the fire. It was always burning since the world's been turning. We didn't start the fire. No, we didn't light it, but we tried to fight it. Joseph Stalin, Malenkov, Nasser and Prokofiev, Rockefeller, Campanella, Communist bloc. Roy Khan, one per run, Toscanini, that run, Din Bin, Pooh, Falls, rock around the clock. Einstein, James Dean, Brooklyn's got a winning team. Davy Crockett, Peter Pan, Elvis Presley, Disneyland, Bardo, Budapest, Alabama, Khrushchev, Princess Grace, Peyton Place, trouble in the Suez. We didn't start the fire. It was always burning since the world's been turning. We didn't start the fire. No, we didn't light it, but we tried to fight it. Little Rock, Astronaut, Mickey Mantle, Kerouac, Sputnik, Joe and Live Bridge on the River Kwai, Lebanon, Charles de Gaulle, California, baseball, start weather, homicide, children of the Little Mile. Buddy Holly, Ben-Hur, Space Monkey, Mafia, Hula Hoops, Castro, Edsel is a no-go. U2, Syngman Rhee, Payola and Kennedy, Chubby Checker, Psycho, Belgians in the Congo. We didn't start the fire. It was always burning since the world's been turning. We didn't start the fire. No, we didn't light it, but we tried to fight it. Hemingway, Eichmann, Stranger in a Strange Land, Dylan, Berlin, Bay of Pigs invasion, Lawrence of Arabia, British Beatlemania, Ole Miss, John Glenn, Liston Beats, Patterson, Pope Paul, Malcolm X, British politician, sex, JFK, blown away. What else do I have to say? We didn't start the fire. It was always burning since the world's been turning. We didn't start the fire. No, we didn't light it, but we tried to fight it. Birth control, Ho Chi Minh, Richard Nixon, back again, moonshot, Woodstock, Watergate, punk rock, Reagan, Palestine, terror on the airline, Ayatollahs in Iran, Russians in Afghanistan, Wheel of Fortune, Sally Ride, heavy metal, suicide, foreign debts, homeless vets, AIDS, crack, Bernie gets, hypothermics on the shore, China's under martial law, rock and roller, cola wars, I can't take it anymore. We didn't start the fire. It was always burning since the world's been turning. We didn't start the fire. But we didn't go, but it was on and on and on and on and on and on. We didn't start the fire. It was always burning. come up to meet you, tell you I'm sorry. You don't know how lovely you are. I had to find you, tell you I need you, tell you I set you apart. Tell me your secrets and ask me your questions. Oh, let's go back to the start. Running in circles, coming in tails, heads on a science apart. Nobody said it was easy. It's such a shame for us to part. Nobody said it was easy. No one ever said it would be this hard. Or take me back to the start. I was just guessing at numbers and figures, pulling your puzzles apart. Questions of science.